everybody, it's Mrs. Tellas. This is day 2 of 9.5. This is actually our last learning that we are doing today. It's the last time I'm going to be teaching you, and then you're going to move on to somebody else next year. All right, so here we go. Section 9.5, and we're going to be kind of reviewing the quadratic equation, but we're also going to be looking at quadratics and deciding what is the best method to find the solutions. Because you won't always use the quadratic family. You won't always use square root. I will never graph, not unless I'm absolutely made to. I will factor whenever possible. So I'll be checking every single one to see if it factors. All right, so here we go. Day 2. All right, 4 ways we've used to solve quadratics. My favorite, factoring. Okay, another favorite, square root. Quadratic equation or quadratic formula. And then my least favorite would be graphing. Okay? So today we're going to decide when it's best to use each method. What would be some reasons we would choose each one? Well, let's go back up here. So we want to choose factoring if it factors. So if it's a factorable equation, we're going for it. We're going to factor it. Okay, we would choose square root when there's only an ax squared plus c, and both of these are perfect. That's when I would choose square root. Okay, there can't be a bx because then I can't put 2 terms on each side and take the square root. There's an extra term. Okay, I would choose quadratic formula last when it's not factorable. And I would never choose graphing. Unless maybe it was already graphed for me and I could just look at the picture and see where it crossed the x. Then I would maybe choose it. But I would never choose graphing. All right. So here I have a chart. So if you have a graphing calculator, you might choose graphing. The square root equations that has no x or bx term. Factoring can factor easily, and quadratic formula cannot be factored easily. And then we didn't use completing the square. We didn't learn that. It's not a standard, so we're going to scratch that one. All right, so here we go. Looking at that first one. Which method would you solve each equation and why? So notice on this one it has 2 terms. There's no GCF. I'd probably use square root here even though these aren't perfect. So if I add 1 to both sides, there's no bx. And then divide by 3, and then take the square root. That would be what I would do on that one. Now you could use quadratic formula there, but it will not factor. So factoring's out on that one. So if I look at number 2, I think I'd try to factor that. So as I look here, factors of -6 that give me -1. So, well, let's see, 2 times 3 and 6 times 1 comes to mind. So 2 times 3, they have a difference of 1, so it can't be this one. And I need a negative, so that means the big one's going to be negative. So this just factors like this. X plus 2, x minus 3 equals 0. So I set both of the parentheses equal to 0, and I solve. So that first one is -2, and that second one is 3. So I'd use factoring here for sure, because it factors. Okay, so let's look at number 3. All right, number 3, I'm looking for factors of 18 negative. They give me -7. Ooh, I'm thinking 9 and 2. -9 times 2 is -18. If I add them, I get -7. Yeah, I'd use factoring there too. So let's guess and check it. Let's see if you remember how to guess and check. So 2x squared would have to be 2x and x. And 9 could either be 1 times 9 or 3 times 3. Well, and I want one of them to be -9x and the other to be positive 2x. Well, this one's already 2x. So that means this has to be a +1. So I'm using this one. And this one's negative 9x, and I've got the x, so I'd have to put the negative 9 there. Okay, and that's a 0. It looks like a 9, but it's a 0. So then I just set them both equal to 0. 2x minus 9 equals 0, and x plus 1 equals 0. So add 9 and divide 2. So my first solution is 9 over 2, or 4.5, and my second solution is negative 1. So there are two solutions. And the last one, I noticed that it's already separated, and all I have to do is get rid of the 5 on the x squared so I can divide it out here and here. And then I'm taking the square root. So that one's plus or minus 5. Square root would definitely be the best way to do that. Now you could factor it. You could have subtracted 75, took the GCF of 5 out, and then it would have been a difference of square, and you could have set those both equal to 0. That would have worked. Quadratic formula will also work on all of these. You'll get the same thing. Regardless of the way that you choose, you still get the same answer. Okay, so really it's a matter of preference. There's really no one right way. If you really like quadratic formula and you want to do it all the time, you can. It seems like a lot of work to me, but completely up to you. If you hate factoring, then you're going to want to stay away from factoring. Okay? All right, so number 5 says use any method to solve, round your answer to the nearest hundredth if necessary. So as I look at that, I think, can I factor it? If I can factor it, I want to do that. So let's go over here. I need factors of 36. They give me negative 12. So both have to be negative. So it's definitely not 1 times 36, 2 times 18, 3 times 12, 4 times 8. I think I found it. Okay, they both have to be negative because it's a positive and they add up. This one factors. I'm going with factoring. So x minus 4 and x minus 8 equals 0. X minus 4 equals 0. X minus 8 equals 0. And here I get 4. And here I get 8. So my two solutions are 4 and 8. Remember what that means. That means where does the parabola cross the x-axis? It crosses at 4 and 8. Remember, they're called solutions, they're called roots, they're called zeros, they're called x-intercepts, and I did not have to round this one, even though, notice it says if necessary. It says round if necessary. It was not necessary. All right, let's try number 6. Okay, so let's see if it'll factor. So I've got an a other than 1, so 3 times 5 is 15. Factors of 15 that give me negative 1. 1 times 15, well, that gives me 16. 3 times 5 gives me 8, or if I subtract 2, so factoring is not going to work. I'm going to have to use the quadratic formula. So I'm going to get rid of that. All right, so this, I know right now that I'm going to get a decimal answer, because when it won't factor because the roots are a decimal, okay, or a non-integer. All right, here we go. It's already in standard form. A is 3, B is negative 1, C is 5. So we're plugging it into the formula. X equals negative negative 1 plus or minus negative 1 squared minus 4 times 3 times 5 over 2 times 3. Okay, so I'm going to work right here and right here first. I'm going to go ahead and do each piece of this. So x equals 1 plus or minus, use my calculator for what's underneath. So 4 times 3 times 5, that gives me negative 59 under there. Okay, hopefully you were just like, oh, it's a negative under the radical. That's not possible. So since it's a negative under the radical and it's not possible, the answer is no solution. Okay, and what does that mean? It means that it is a smile or a parabola that's above the x-axis and it's opening up, so it's never going to cross the x. Okay, and again, I know that because this is negative right here. The discriminant is a negative 59. All right, number 7. Use any method to solve. Write your answer to the nearest hundredth if necessary. Okay, what I notice is there's no x term. Do you also notice that? I hope you do. Okay, there's an ax squared and there's a c. Actually, there's 2 c's. So I'm going to move the 24 over. I'm going to try to use square roots here. So add 24 here and here. 8x squared equals 33. Let me check that. 24 plus 9. Yep. All right, then I'm dividing by 8. So x squared equals 33 divided by 8. That gives me 4.125. Now I'm taking the square root. Remember, I have to remember both of them, the plus and the minus. So the square root of 4.125 is a very long irrational number, 2.0310. But it's set in the directions nearest hundredth. So that's the 3. So the 1 decides and the 1 says stay. So my roots are plus and minus 2.03. And it really is an approximation because I'm rounding. Okay, that's why it's not exact. All right, but it's close. It's really close. All right, number 8. It's got to be x. I think I'm going to try to factor this. Now, if I used quadratic formula, a would be 1, b would be 4, and c would be 0 because there's no c. Okay, but I'm not going to use quadratic formula because I can factor this. So as I look at those two terms right there, they have a GCF. Hopefully you see it, of x. So I'm going to divide the x out. That leaves me with x plus 4 inside the parentheses. So now I can set anything with an x equal to 0. So x equals 0, that's my first solution, and x plus 4 equals 0. Well, I can solve that, and I get negative 4. So I have two solutions, 0 and negative 4. That was a ton easier than going through quadratic formula. All right, number 9. It says use any method to solve, round your answer to the nearest hundredth if necessary. So let's see if it will factor. I don't think it's gonna. 11's prime, so let's see. Factors of 11 that give us 5. 1 times 11, that adds up to 12 and it subtracts 10. Neither one of those give me 5 and I don't have any other choices. That doesn't work. Factoring is out. Square root is out because it's got this bx term. I'm not graphing it, so I guess it's quadratic formula. So a equals 1, b equals 5, c equals 11. And I'm just taking that right from the quadratic equation there. All right, so let's use the formula. X equals negative 5 plus or minus 5 squared. Whoops, it's minus, not plus, Mrs. Tellas. Try that again. Minus 4 times 1 times 11 over 2 times 1. All right, so negative 5 stays the same in the front, plus or minus. Now I'm going to use my calculator on the back portion, the discriminant. So 5 squared minus 4 times 1 times 11 is negative 19. There's a negative again, and it's under the radical sign, which means hopefully you know the answer is no solution. Very good. And again, it's no solution because it's got a negative under here. And if you put that negative in the calculator, second, x squared, negative 19, it says domain error. So you cannot get a number out of that. So since you can't get a number out of that, it is no solution. What it means is it doesn't cross the x-axis. Okay, number 10. Use any method to solve. I know square root is out because it's got to be x. Let's see if it will factor, because if it will, we want to use factoring. It's easier than quadratic formula. Less chances for a mistake. Oh, I did that backwards. Let's start again. So I need factors of 35 that give me 12. How about 7 times 5? Don't those multiply to 35 and add to 12? This factors. So x plus 5, x plus 7 equals 0. So now I just set the parentheses equal to 0 and solve both of those little one-step equations. So I'm subtracting 5. So negative 5 is my first root or solution. And I subtract 7 on both sides. Negative 7 is my other. So I have two solutions there. And I didn't have to round because it factored. And I didn't have to use quadratic formula. But if I did use quadratic formula, it would work. If I graphed it, I would still get negative 5 and negative 7. If I used the formula on it, I would still get negative 5 and negative 7 if I did it correctly. You can use any method. You should still get the same answer. Okay, so we're all done. Your assignment is on page 521. It's 25 to 44 all. And I have taught you everything I'm going to. So Monday, we'll do a review over 9.1 to 9.5, leaving out 9.4. And then Wednesday will be our last day, and that'll just be a catch-up day. So if you have anything that's still due, that you haven't done, that you want credit for, you are more than welcome to turn that in on Wednesday. And then grades are due on Thursday, I believe. So it's been fun. It's been a fun year. I'm going to miss you guys, and I hope you have a good summer and come see me next year. Bye!